product of the highest technology and engineering content requiring excellence from all affecting its production. We are all aware of the stringent requirements that NASA places on those who build satellites and manned space vehicles. The space shuttle is a stunning technical achievement, and yet a tiny amount of contaminant stopped the second launch of this 4.5 million pound craft. How small was that contaminant? It weighed less than 2 milligrams. Compared to the shuttle, it was 100 billion times smaller. But what does that have to do with video discs? In a video disc, a particle 1/10 billionth the size of the product will create a rejectable condition. Typically, it will launch the stylus 1,000 microns down the disc, 500 times the size of the stylus, or the equivalent of a 6-foot man jumping from one end to the other of our Rockville Road plant. Very small particles can and do cause large problems in all high-technology industry and present one of our greatest challenges in detecting and locating them. Let's take a look at a video disc closely. Here, under 1,000 powers of magnification, we can see the destroyed surface caused by the stylus riding over an embedded particle. To be able to see the individual grooves, we would have to magnify a disc 200 times, as shown in this photograph. But to be able to see the video information in the bottoms of the grooves, we would have to magnify the disc 10,000 times. You see, we deal in a microscopic world in the manufacture of the video disc. For perspective, if a disc were as thick as a 4-story building is tall, the grooves would only be a 1/2 inch wide, a 1/16 inch deep, and the information only as thick as 5 sheets of paper. On the same scale, the disc as thick as a 4-story building, it would be a mile in diameter. Using the Monument Circle for a hub, it would cover Indianapolis from East Street to West Street. Extremely accurate replication in plastic is what makes the video disc work, and that is why each operation in the manufacturing of video discs requires skill and attention to minute detail. Let's take a look at the visual inspection of a video disc. As soon as the transfer arm has gone in and another disc is being pressed, we can collect our sample. At the press, they will be examined for gross defects that would require immediate shutdown. From there, we can transport it to the inspection area, where we'll look for minute defects, things that require greater attention to detail. Here are some causes for immediate shutdown of a press. A cracked or chipped edge, as shown here, should be immediately communicated to the setup operator and his supervisor. Gross staining or scorched discs should also be communicated to pressing supervision and QA supervision. For the more minute details, we'll examine the disc closely under an inspection light. Here we'll look for such things as dents, stains, scratches, blisters or voids, and other defects found on discs. Once these defects have been found, they will be mapped. We'll go into this in a little detail. To map a defect, we would first locate it with our eye and then mark on the disc with a scribe its location. In the case of dents and voids, they may be circled, but stains which are large should be indicated with parallel lines. This mapping then is continued by placing the template on top of the fixture. On the template are the minutes of play. These should be recorded so that a fresh sample can be checked in playback evaluation to determine if these suspected defects will be cause for shutdown. Do not play a marked sample. Ultimately, all physical and electronic characteristics will be checked in accordance with specified procedures. To be proficient as a process inspector, we will require that you practice on the job the skills learned in this program. Here are a few of the tools that are used to check for warp, acceleration, and TIR, center and radius dimensions, gross warp, video profile, number of kicks, audio and video signal to noise, time-based stability, and defect gate. Each of these instruments will be gone into in detail in the next modules. RCA Select Vision Learning programs are divided into modules. This program is Module 1 of the Quality Inspection of Video Discs. In these learning programs, each module addresses an objective. An objective is very simply something that we want you to be able to do in your job. In this first module, the objective is to be able to recognize both the gross and minute visible defects that occur to video discs, and to be able to correctly handle a disc so as not to cause defects in its inspection. In addition to that, we want you to be aware of some of the basics of video disc technology and why it's important that you wear such things as hairnets, spit masks, and gloves. Module 2 for matrix platers. The substrate to master process. A video disc begins with a videotape having been cut into the copper surface of a substrate. The copper was plated onto the aluminum base in the matrix department. Metal plating has been done for years, though nowhere has the result required such microscopic perfection. In matrix, a process called fanning out the parts is performed. We fan out the parts so that we can get more from each substrate. This is a very critical process because the copper is far softer than the nickel children parts and stains more easily. Additionally, if parts are lost at this stage, there is a more serious consequence. In this graphic picture, we can see what a fan-out is. Here, 5 masters have been used to create 5 mother parts, which have then been used to make 5 stampers each. From these stampers, 62,000 discs can be had, as one substrate can yield 5 masters, which could then produce 25 mothers and 125 stampers. But if, due to some problem, only 2 masters could be made from that substrate, then only 10 mother parts could be made at best, and only 50 stampers, yielding only 25,000 discs. In this case, if there were sufficient orders for that title, a new substrate would have to be made and the process started all over. In this process, the potential for loss can be high, but by carefully following the procedure that you will see, the potential is reduced. Whenever working around substrate parts, in addition to the lab coat and hairnet required in matrix, always wear the particle mask and rubber gloves. Copper to nickel duplication begins by checking the temperature of the passivation cleaning solution and the rectifier settings of the tank. If they are not correct, they must be set as follows. The passivation tank should be at 65 degrees plus or minus 5 degrees centigrade. By adjusting the controller, this temperature can be achieved from between 60 to 70 degrees centigrade. On the rectifiers of the tank, the amp hours should be set at 350. The dwell timer at 0.0. The plate 1 timer at 30 minutes at 20 amps, and the plate 2 timer at 100 amps. To begin, we open the can which contains the substrate and compare the number on the metal part to the paperwork which comes with the storage container. If they agree, we would continue with the process, but if not, we would close the can and return them to the vault. Next, the substrate is checked for obvious damage such as stains or scratches. Then, the substrate is laid on the sink rack, face up, and the deionized water is turned on hard enough to completely cover the substrate with runoff. Now the edge is carefully roughened. Using red Scotch-Brite, we rough a 1/4 inch wide around the substrate, turning it in 1/4 degree turns and rubbing the edge. This is to avoid pre-separation during plating of the master. When the finish is gone, we finish this process It is important to keep the water running during this step to avoid debris from being washed into the signal area of the substrate. Having roughened the edge, we then mount the substrate on a 3-point rack and lock the retaining ring securely while the water is still running on the substrate. With this complete, we will rinse the substrate for 30 seconds in the deionized water rinse tank, raising and lowering the part during this 30 seconds. Then, we submerge the substrate completely in the passivation cleaner for 10 minutes. After setting the timer for 10 minutes, we will want to go to the tank where we're going to mount it and change the contact head. This is done at each setup for making a master part. First, a tray is installed into the tank to prevent any dirt, salts, tools, or parts from falling into the tank, which would contaminate the solution. Then, by removing the screws, the contact plate can be removed. It should be replaced and set aside for cleaning at a later time. Before installing a new contact plate, burnish the contact surface of the shaft and make sure that it's bright and shiny. Then, secure the contact plate. Make sure that the recesses for the screw heads are on the outside so that the screws will be flat or slightly below the surface of the contact plate. When the screws are tightened, tap the plate at the center with a screwdriver and see that it does not rotate. It is essential that this plate be tight. When the 10 minutes have expired, we remove the substrate from the passivation cleaner and rinse it again in the deionized water for 30 seconds, again raising and lowering the part. We then return the substrate to the sink rack and remove it from the 3-point rack. Now we place it on the sink rack and again turn on the deionized water fast enough to have it run completely off the surface of the substrate. We will then pick up the master plating ring and, while holding it over the floor, rinse it well and inspect the seal for damage. If the seal is torn or damaged, it should be replaced. Now place it on the substrate, pressing firmly. Now rinse the cover of the aluminum plate over the floor and away from the sink to avoid splashing contaminated water onto the surface of the substrate. At this point, shut off the running water over the substrate and place the substrate cover on the plating ring, holding it in both hands. We then screw the center hole knob clockwise in until it fits tightly into the substrate, and tighten down the substrate cover with the large holding knob, turning it clockwise. Now we may carry this assembly to the plating tank and screw it onto the head clockwise until it seats well. Check to make sure that it's tight at this time. Then unscrew counterclockwise the large holding knob and remove the protective cover. Rinse the substrate with deionized water for 5 to 10 seconds. Unlock and lower the substrate into the plating solution and turn on the rectifier. Confirm that 20 amps of current is achieved. While the master is plating, write up the paperwork, the date, shift, tank, and position on the ticket, and enter it into the DMAX computer. At this time, you should clean the used contact plate using the red Scotch-Brite until it is bright and shiny. It is very important that after about 10 minutes that you check the amp meter and confirm that contact has not been lost. If the amperage goes down, then a burnout is in progress, and this is a difficult situation which must be remedied immediately. When the cycle is complete, the alarm will ring. Push the off button on the rectifier on tanks N1 and turn the rectifier to 0 on tank N2. Lift the head out of the solution and lock it in the up position. Rinse the composite, which is the substrate and master, while they're still together. Rinse the aluminum cover plate over the floor, both front and back, and place the cover plate on the plating ring and secure it with a large holding knob clockwise. Unscrew the assembly from the plating head and carry it to the sink. At this point, we will clean the back of the substrate with Scotch-Brite. This is to improve contact and reduces the potential for burnouts. After Scotch-Briting, make sure to rinse it well. Now place the assembly securely on the sink rack and unscrew the holding knob counterclockwise and remove the aluminum cover. Remove the plating ring and rinse off the composite part. Now the composite is ready for separation. There are two methods for separating composite parts. In this first method, the substrate will be returned to the vault after we have separated the master part. We place the composite part on a 3-point rack and secure the retaining ring. Next, we take this composite and the storage can into the separation room. We will rinse the composite part in deionized water for 30 seconds, raising and lowering the part. Next, we will rinse the composite in alcohol spray rinse number 1 for 30 seconds to remove the deionized water. Make sure that the rack is at least 1 inch above the rinse level of the water. Raise and lower the composite and make sure that one of the spray jets sprays into the center hole for at least 5 seconds. Then, rinse the composite in the second alcohol spray rinse for 30 seconds, raising and lowering the part. Now, we will carry the composite to the Freon tank. Lower the composite into the Freon vapor chamber slowly until the solution is washing down the entire surface. The part should be held in the vapor chamber for 5 minutes. Slowly withdraw the parts from the vapor so that a smooth, straight vapor line is maintained. A jagged line indicates too rapid a withdrawal. A stain will occur if it is removed too rapidly. If you cannot get a straight line while withdrawing the part, then it should be replaced into the vapor and your supervisor should be called. When the part has been removed satisfactorily, blot the center hole with the tip of a laboratory towel and remove any flash or burrs from the center hole. Now lay the composite into a cleaned substrate storage tray with the master up. Using a round-edged X-Acto knife, pry up the edge of the master until the seal gives, as you see here. Next, lift the edge enough to get a finger grip on the master part, and put your other hand exactly on the opposite side of the master at the edge and press down firmly. The master must be lifted from the substrate in a smooth and continuous motion which may not be stopped once it has been started. If stopped, it will damage both parts. When the master has been removed, it should be placed on the etching table for etching. In the case of master cam painting, in which we immediately will make another master from the substrate, we use this procedure. Place the composite part on a rack beside the sink and hold it by the edge. Wipe both sides of the composite dry with a laboratory towel. Make sure that before starting, you wipe out any container that will be reused for containing metal parts. Make sure to use the edge of a towel to sponge out the center hole, and lay the part flat on the work table. Remove any flash or burrs from the center hole. Again, using the round-edged X-Acto knife, pry up the edge of the master until the seal gives. Pry up the edge enough to get a finger grip on the master, and with your hand on the opposite side, holding the master firmly to the substrate at the edge, lift the master from the substrate in a smooth and continuous motion. Again, this cannot be stopped. If damage occurs at this point, the fan-out will be greatly reduced. After the master has been removed and placed in the master tray, we can place the substrate on the sink rack and return to step 4 of the master to substrate to master duplication. This completes the master from substrate process and the methods used to separate, both in a campaign mode and in a master duplication mode.